Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Agriculture, SOA, Certificate in Beekeeping, CIB, OAPI 01 to Management of Honeybee Colonies, Block-1 Bee Health Management, Unit-3 Protection from Poisoning, 3.0 Aims and Objectives. After going through this unit, you will be able to times explain the causes of bee poisoning, times assess the symptoms of bee poisoning, and times adopt methods to reduce the bee poisoning. 3.1 Introduction. In the previous units, we have learnt about the bee enemies and diseases causing loss in the beekeeping. The pesticides used in agriculture, horticulture and in field and forest situations to control wide range of insect pests. Diseases and weeds are also harmful to the honeybees. During the last 4 decades, the consumption of pesticides in India has increased several folds. Most of the farmers apply large amount of pesticides at regular intervals, and indiscriminate use of pesticides causes adverse effects on agroecosystem, one of which is toxicity to honeybees. Pesticides are one of the main agents of poisoning honeybees and other pollinators. Honeybees are very much susceptible to many groups of pesticides. Pesticidal poisoning is recently overshadowing all other problems in apiculture. Selective use of insecticides is one of the requisites for integrated pest management, LPM. In this context, selection of insecticides which are effective against target pests but less toxic to pollinators should be used and will definitely minimize the losses of bees in the colonies. In recent years, many insecticides have been screened for their efficacy to target pests and their toxicity to honeybees. Mortality of bees is high when most toxic chemicals are applied during blooming period of the crops. It is not possible to quantify losses in terms of food production and to assess financial value of bees killed. Let us study further about bees and bee poisoning. 3.2 Sources and causes of bee poisoning. The main sources of honeybee poisoning are I. Pesticidal poisoning by use of chemicals like insecticides, fungicides, herbicides, weedicides used in agriculture. 2. Plant poisoning may occur due to toxic nectar, pollen or poisoned honeydew produced by some plant species. 3. Industrial poisoning by gases emanating from the industries, which may cause bee poisoning. The contaminated pollen is the main source of poisoning. Near the factories, the bee poisoning hazards are observed in the following situations: times when the pesticide is applied during the blooming period of bee forage crop, times when the pesticide is applied while bees foraging on the crop, times when bees fly to the treated plants and collect contaminated nectar and or pollen, bee feeding on contaminated food and water sources. Times contamination of flowering cover crops when orchards are sprayed, times drift of toxic chemicals from the point of application onto flower, pollen and nectar or across apiaries. Insecticidal dusts adhere to foraging bees and ultimately become packed with the pollen onto the hind legs. Ego-carbaryl is especially dangerous because it may be stored with pollen and kill newly emerged workers the following season. Times use of broad-spectrum insecticides, chlorinated hydrocarbons, synthetic pyrethroids. Times use of insecticide formulations like dust, EC, which are more harmful than WP and granules. Times use of insect growth regulators may inhibit brood production. Times use of diesel oil as a carrier in insecticide formulations. 3.3 Symptoms of bee poisoning. Specific symptoms are caused by poisoning of different groups of pesticides in bees. The general and most common symptoms of bee poisoning are times appearance of large number of dead bees near the entrance or in and around of beehives or colonies, and in fields, times dead bees on the top of combs or bottom board, times paralyzed bees crawling on nearby objects with trembling appendages, times bees lose power of orientation and may perform abnormal communication, dances on the horizontal alighting board at hive entrance, times legs, wing and digestive systems of bees stop functioning, times bees are irritated and become aggressive, they sting heavily and lack of recognition by guard bees, times queen may behave abnormally and lay eggs in purpattim, times fighting among bees, times sudden decline in food storage and brood rearing, times abdomen becomes distended and regurgitation of honey stomach contents, times dead and deserted brood in the hive, times lack of foraging bees, times depleted population of bees in the colony, longevity of adult bee is reduced, times contamination of bee products. The specific symptoms of poisoning in bees by different classes of pesticides are given below in Table 3.1 Class of pesticide, Table 3.1 Symptoms of poisoning in bees by different class of pesticides, Class of pesticides, Example of pesticides, Symptoms of poisons. Organophosphorus parathion, methylparathion, diamethate, nald, mebenphos, diazinon, dichlorovos, TEPE, monocrotophos, phorate, malathion, phosphamidin, chloropyrifos, times regurgitation, wet bees, disorientation, lethargy, times perhaps distended abdomen, times erratic attempts to clean, selves, tumbling about, paralysis, times ultimately die, wings held away from body but usually remaining hooked together. Times high percentage of poisoned bees die near the colony, chlorinated hydrocarbons, aldrin, chlordane, DDT, dieldrin, heptachlor, lindane, coxaphene, times erratic movements, trembling, times hind legs dragged as if paralyzed and wings held away from body but usually remaining hooked together, times high percentage of bees die in the field or near apiary, carbamates, carbaryl, carbofuran, aminocarb, dimethylen, mexacarbate, methomyl, times aggressiveness, times erratic movements, times unable to fly as though chilled followed by paralysis, morbidity and death, times most bees usually die at the colony, times queens often cease egg laying, times hive bees initiate supersedure cell, times raising queen cell even before egg laying by the newly mated queen resumes. Dinitrophenyl dinocap, carathne, GNOC DNOSBP, times similar to symptoms of chlorinated hydrocarbons but often accompanied by regurgitation of substances in digestive tract as is typical of organophosphorus insecticides, times most affected bees usually die at colony, botanical and pyrethroids, nicotine, rotenbun, rhinia, subdilla, pyrethrum and pyrethroids, alethrin, resmethrin and cismethrin, perhaps regurgitation from highly toxic pyrethroids together with erratic movements and then inability to fly, times stupefaction followed very soon by paralysis, morbidity and death. Times bees often die between foraging area and colony. 3.4 Guidelines to assess the extent of bee poisoning by pesticides. The mortality data given below can be used as guidelines to assess the extent of bee poisoning by pesticides. Number of dead bees day at entrance, level of poisoning. Low normal death rate 200 to 500 low, 500 to 1000 medium, more than 1000 high. Source FAO Bulletin 1988. 3.5 Effects of bee poisoning. 3 types of harmful effects evident in apicultural beekeeping are 1. Loss in production of honey, 2. Contamination of bee products, 3. Reduction in the yield of cross-pollinated crops. The harmful effects may be due to the direct exposure of honeybees to pesticides or through indirect contact with their residues. Direct exposure occurs from treatment of beehives for disinfestation purpose or bees visiting the field at the time of spray. The indirect exposure occurs from the spray drift or bee foraging in sprayed crops. 3.6 Selection and use of pesticides. Pesticides are used in agriculture, horticulture and for vectors control in public health programs. Significant amounts are also used in forestry and livestock protection. They are classified in many different ways. Different groups of pesticides based on target organisms are as follows. 3.6.1 Major groups of pesticides. 1. Insecticides, chemicals to kill or control insects, endosulfan, malathion. 2. Rodenticides, chemicals exclusively used to control rats, e.g. zinc, phosphide. 3. Acaricides, chemicals used to control mites on crops and animals, example, dicophol. 4. Nematicides, chemicals used to control nematodes, e.g. ethylene dibromide S. Fungicides, chemicals used to control plant diseases caused by fungi or inhibit growth of fungi in crops, e.g. copper oxychloride. 6. Herbicidal weedicides, chemicals used to control weeds, e.g. 2,4-D glyphosate. 7. Chemosterilants, chemical substances that sterilize insect pests. 8. Molluscicides, chemical substances that prevent, repel, destroy or inhibit growth of mollusks. 9. Plant growth regulators, chemical substances that cause acceleration or retardation of rate of growth or rate of maturation of plants. 10. Defoliants. Chemical substances that cause plant leaves to die and fall away. 11. Desiccants, chemical substances that cause draining of moisture out of plants and causing them to dry. 12. Attractants, chemicals that attract insect pests. 13. Repellents, chemicals that repel insect pest from a treated plant. 14. Biopesticides, formulated products of plant and microbial origin, example, nimbecidine, Bacillus thuringiensis, NPV. 3.6.2 Type of pesticides. 1. Contact poison, the chemicals or toxicants which bring about death of the pest by means of contact, e.g. endosulfan, malathion, deltamethrin. 2. Systemic poison, chemicals when applied to plants or soil are absorbed by foliage or roots and translocated through vascular system of plants and cause the death of the insect feeding on the plant, e.g. dimethoate and phosphamidin. 3. Fumigants, the chemicals or toxicants which enter in vapor form and kills the pest, e.g. aluminium phosphide and methyl bromide. 3.7 Pesticide formulations, it is a formulated material which is ready for use as pesticide. Type of pesticide formulations. I. Solid formulation for dry application, e.g. dust. D. Granules. G. Poison, baits, pellets and tablets. N. Solid formulations for wet application by spraying, e.g. vegetable powder. L. Liquid formulations for spraying, E.G. Emulsifiable concentrates, BC. Suspension concentrates, SC. Flowable, F. Low volume concentrates, LVC. 4. Gaseous formulation for application as gas or vapor, e.g. fumigants, aerosols, smoke generators. 3.8 Categories of pesticides on the basis of their toxicity to honeybees. Pesticides are also grouped under different categories depending upon their relative toxicity to bees. This can help in choosing and selection of appropriate pesticides, particularly when alternate choices for a pest control are not available. There are 3 main categories of pesticides, which are as follows. Category I, highly toxic pesticides. These pesticides are highly toxic and cause severe damage to bees. They should not be applied on blooming crops or weeds. Their residual toxicity is usually high, even after 10 hours of spray. Highly toxic insecticides, carbaryl fenvalerate, carbofuran monocrotophos, carbophenethine oxidamytin methyl, chlorpyrifos parathion, cypermethrin permethrin, deltamethrin phorate, dichlorvos, DDVP, phosphamidin, dicrotophos quinalphos. Dimethoate Category 2 Moderately toxic pesticides. These insecticides are moderately toxic to bees and should be applied during late evening, night or early morning hours when bees are not actively foraging. Their residual toxicity is usually low within 3 hours of spray. Bees should not be exposed to these insecticides. For minimal hazards to bees, the dose, timing and methods of application are very important. Moderately toxic insecticides, DDT hinosin, diazinon lindane, dieldrin malathion, endrin metacistox, ethyl parathion methyl dimetin, phenytothion methyl parathion, fendian mebenphos, formothion heptachlor, HCH trichlorphon, 2. Moderately toxic fungicides. Bavistine difolitin, carbendazole foltaf, dithane hexacap, Category IL, relatively non-toxic pesticides. Pesticides under this category are least toxic to bees and can be applied at any time with reasonable safety to honeybees. Their toxicity is usually low with direct application. Relatively non-toxic insecticides, Bacillus thuringiensis methoxyclar, chlorobenzylate morestin, dicophol nicotine, dimite nuclear polyhedrosis virus, endosulfan fosolone, Ethylene pyrethrum, Menazone subdilla, 2. Relatively non-toxic fungicides, Analazine dinocap, Binomial dodine, Bordeaux mixture falsid, Catafol thiram, Captain ziram, Cuprous oxide polyram, 3. Relatively non-toxic herbicides, defoliants and desiccants. Alaclar cynazine, Amitrole duro, MMT-methazole, Atrazine nitrofen, Bromosil all sprays. 3.9 Factors affecting bee poisoning. The factors contributing large-scale bee poisoning are as follows. 1. Pesticide formulation. Dust formulations are more hazardous to bees than sprays as these contaminate the atmosphere and can be carried to neighboring localities. 2. Selectivity of insecticides. There are some insecticides which have little effect on honeybees when applied as sprays, e.g. endosulfan. Selection of such insecticides is beneficial and safe to honeybees. 3. Period of application. Bees visit plants during flowering period of plants. Pesticide application directly on flowers during flowering period causes greater losses to the bees. 4. Time of application. Bees are generally active during daytime. They start foraging early in the morning and generally return to the hive by the evening, particularly during dehiscence time. More bees visit the flowers and application at this time kill bees more than other times. Pesticide applications during this period are, therefore, very hazardous to the bees. 5. Method of application. Ground application of pesticide is safer than aerial application. Bees get less time to escape the drift of insecticides. The systemic insecticides applied on the blooming crop may cause hazard to bees while collecting nectar and or pollen from flowering plants. Fine sprays are safer than coarse sprays because the amount of insecticide coming in contact with the pollinating insect is less as compared to lethal one in coarse sprays. 6. Weather. Warm and sunny weather is conducive to the foraging by bees. When there is a prolonged dull weather, the foraging activity is reduced considerably and insecticides can be applied to field crops. 7. Colony strength. Populous colony always suffers greater losses than small colonies because in few cases more foragers are exposed to the pesticides. 8. Age and body size of the bees. Newly emerged bees are more susceptible to insecticides than older bees. Smaller bees likewise are more susceptible to insecticides than the larger bees because their body surface area is larger in relation to their body weight. 9. Attractiveness of the crop. Some crops, notably rape and mustard, are highly attractive to bees which will forage from colonies up to 3 kilometers away or more. These crops remain attractive until the very end of flowering. It remains attractive even in cool and dull weather when they may not visit other crops. All precautions, thus, are required to be undertaken while spraying on these crops to protect bees. 10. Distance of the apiary. Honeybees normally have a foraging range of 1 to 2 kilometers from the colony. Application of the pesticides within 2 kilometers of the colonies, therefore, proves detrimental. 3.10 How to reduce bee poisoning. Bee poisoning by pesticides can be reduced to maximum extent, and bees and bee colonies can be protected by following certain precautions and pesticide management practices. These practices should be kept in mind and have to be adopted by the beekeepers, farmers and pesticide applicators. Some of the measures to be practiced are given below. 1. Non-toxic and safer insecticides to the bees should be applied only when crop on bloom is heavily infested and treatment is worthwhile or the use is justified. For example, endosulfan and fossalone are insecticides non-toxic, less toxic to bees. Further, use as far as possible the biogens and botanicals like Bt products, NPVs, neem, etc. 2. Avoid the application of a pesticide to bee flora in bloom and also do not apply on cover crops or intercrops in bloom even if main crop is not in bloom, and vice versa to avoid pest drift problem. 3. Insecticides having selective action and selective formulation causing low toxicity to the bees should be used. Pyrethroids generally degrade faster than other groups of insecticides. 4. Always choose and use safest formulation of pesticides that will kill the pest and safe to bees. Times granular formulations are safest to the bees and are also seed treatments. Times dusts are more hazardous than liquid formulations for spray of the same insecticides. Emulsifiable concentrates, EC, are less hazardous and safest for bees than water-soluble or wettable formulations since the former has shorter residual toxicity than the latter. 1. Times do not use broad-spectrum pesticides. Instead, pesticides with shorter residual effect should be used. Times LVC formulations are more hazardous than other liquid formulations. 5. When using pesticides hazardous to bees, the beekeepers should be notified so that they may provide protection to their colonies. 6. Time of application and location of colonies are important considerations. A. Never apply pesticides while the crop is in bloom or while interplants, weeds or adjacent crops are in bloom. B. Never apply insecticides when bees are flying on the crop. Evening or late evening applications depending upon bee activity on the crop are relatively safe. For example, by overnight, toxicity of parathion is reduced by 50%. C. Nights when dew occurs, the toxicity may last longer. 7. Pesticidal dusts and small granules should not be left open or thrown carelessly anywhere because bees are likely to collect such dust during acute dearth periods. 8. Before applying pesticides, the hives may be moved to another place temporarily or they may be confined for a short period. While confining, A. Provide sufficient space in hives. B. Provide proper ventilation. C. Shade in provided to the hive. D. Colonies may be covered with wet absorbent material which helps to reduce the hive temperature. And E. Minimize the period of confinement. The bees must be confined in the hive as long as the pesticide near the hive retains unacceptable toxicity. 9. Treatments during hot weather when bees are clustering on the outside of the hive should be avoided as may cause severe losses. 10. Treating large areas and repeating applications may cause greater damage and bee losses. 11. Insecticides should not be applied when unusually low temperatures are expected afterwards because residues would remain toxic to bees for a much longer time. 12. Primary emphasis should be on the use of integrated pest management programs, IPM, which mainly relies on biological, cultural and mechanical control methods and which tend to minimize the use of chemicals. 13. Care should be taken when discarding the pesticides. These should not be described in open or in water chemicals from where the bee could pick up the pesticide. 14. The combs with contaminated pollen should be removed. 15. Unite weak colonies and provide artificial feeding. 16. Beekeeper should be intimated with the spray schedule so that the colonies may be shifted or closed as the need be. 17. In intensely beekeeping areas, there should be proper and close communication between beekeeper, grower, extension worker to save the bees from pesticides. 18. In crops requiring frequent pesticide applications, apiaries should not be established in such areas. 19. The honeybee colonies should not be located inside the crop fixed but a little away from it prevent bee poisoning, and there should not be located just adjacent the crop either to prevent bee poisoning by pesticidal drift. 3.11 Quick Guide to Minimizing Bee Kills. Look at the screen. 3.1 To care of poisoned colonies. 1. Hives should be closed and moved away from the source of poisoning. 2. The poisoned colonies should be kept in shade and provided with proper ventilation from top and or sides of the hive, not only through the entrance. 3. The combs in the hives be loosened to give ample space for ventilation and provide water inside the hive. 4. Sugar syrup and pollen substitute may be provided to the poisoned colonies. Contaminated pollen stored in combs can be removed by dipping the combs in water and washing by slight shaking, else replace these combs. 3.13 Poisonous bee flora. Plant poisoning is also one of the sources of bee poisoning. It may occur due to toxic nectar, pollen or poisoned honeydew. When bees visit flowers of poisonous plants whose pollen and nectar are injurious, they get poisoned and both adults and the brood in the colony may die. The poisoning of bees from plant products is generally confined to limited areas and, therefore, is much less a problem than pesticides poisoning. Nevertheless, poisonous plants do cause serious losses under certain conditions in limited areas. Symptoms of plant poisoning. In plant poisoning, large number of dead bees are found near the plants, while in pesticidal poisoning, the dead bees one found near the hives. The brood affected by plant poisons may die any time between hatching of the egg and the emergence of the adult. The affected queens may produce eggs which do not hatch. Poisonous flora for bees. No. Scientific name, common name, L. rhododendron arboreum. 2. Rhododendron sp. 3. Aesculus californica, buckbye. 4. A. hippocastanum. 5. A. povia. 6. Astragalus sp. locoweeds. 7. Cyrilla racemiflora, summer titty or leather wood. 8. Cyrilla sp. 9. Tilia sp. 10. Calimia latifolia, mountain laurel. 11. Corin zerocarp as livicta, carica tree. 12. Zygadenus venenosus, death commas. 13. Cuscuta sp. Dodder. 14. Solnum nigrum, black nightshade. 15. Corieria arborea, tutu. 16. Triglochian maritime, seaside arrowgrass. 17. Asclepias subverticillata, old milkweed. 18. Veratrum californicum, western falls hellebore. 19. Veratrum album, hellebore. 20. Hyoscamus niger, henbane. 21. Aesculus hippocastanum, horse chestnut. 22. Senecio jacobea, ragwort. 23. Andromeda. 24. Arbutus unedo. 25. Ferruginum. 26. Hirsutum 27. Thomsoni ponticum 28. Anthopogon 29. Tripetalia panico-ata 30. Euphorbia seguerana 31. Aconitum 32. Gelsemium sempervirens, yellow jasmine 33. Datura metal 34. D. stramonium 35. Hyoscyamus niger 36. Asclepias 37. Ranunculus 3.14. Summary: the use of pesticides has become inevitable in modern agriculture. Pesticides, used on field and horticultural crops or the control of pests, have several detrimental side effects, one of which is killing of beneficial insects like honeybees and other pollinating insects. The pesticides kill the bees directly foraging in the fields and indirectly contaminate the bee forage, and when such contaminated resources are brought to hive, these kill the immature stages developing brood. Selection of pesticides safer to honeybees will definitely minimize the losses of bees in colonies. It is necessary to follow practices which minimize damage to honeybees. There is urgent need to develop the pest management strategies which are environmentally friendly and based on ecological principles. Thank you for watching. We will see you in the next video with the next chapter.